This video focuses on Darkfield illumination. For this video, I will be using a T490 microscope. Darkfield illumination is a lighting method used to increase contrast in low-contrast samples. It's particularly useful for highlighting specific sample material, while other methods, such as phase contrast, are better for viewing interior details. At the heart of Darkfield illumination is a Darkfield condenser. It works similarly to a Brightfield condenser, except it includes an opaque disc, or stop, which blocks direct light from entering the objective lens. Instead, only oblique lighting which is refracted by the sample will enter. This results in certain objects being illuminated while the background remains dark. When choosing a Darkfield condenser, be sure the condenser's numerical aperture is larger than the numerical aperture of the objective lens you plan to use. If the objective lens's aperture is larger than the condenser's, direct light will be transmitted and a dark field will not be achieved. At the dry condenser's upper limit, this image shows noticeable glare. Well above the condenser's limit, the dark field is completely lost. By reducing the aperture of the lens, the dark field may be restored. There are two classes of condenser, dry and immersion. A dry condenser is designed to work with lower magnification objectives with lower numerical apertures. This typically covers objectives up to 40 times, with apertures of around 0.65 or less. An oil immersion condenser is needed for higher magnification lenses, such as a 100 times lens. Due to the high numerical aperture of these lenses, typically 1.25 or higher, a condenser of correspondingly high aperture is needed, especially to maintain high resolution. While this combination will produce an image with improved contrast, it may not be truly dark field due to the objective lens's high aperture. As an option, a variable aperture lens may be used to fine-tune the dark field. By closing a built-in iris, the numerical aperture of the objective can be reduced until the field is adequately dark. Replacing the condenser is a simple process. The condenser can be raised or lowered by using the adjustment knob. While supporting the installed condenser, loosen the locking screw until the condenser can easily slip out. Next, insert the Darkfield condenser fully. Then securely tighten the locking screw. A Darkfield condenser should be centered for optimal results. Although the procedure is similar for dry and oil condensers, there are some minor differences. For the dry condenser, use a low-powered objective, preferably at 10 times. By removing an eyepiece, an image of the condenser's lens can be seen. Adjust the height of the condenser and the stage if necessary, until the opaque disc fills slightly less than the entire image circle, leaving a ring of light. Now, use the two centering screws to move the disc until it appears centered within the ring of light. For the oil condenser, use a high-power objective, preferably at 40 times. By raising the condenser, a dark circle should be visible. Now, use the two centering screws to move the circle until it appears centered. For best results, once the condenser is centered, it should be raised until it makes contact with the slide, and the lamp should be turned up to maximum brightness. When working at high magnification, you'll likely be using an oil objective lens and an oil condenser. Before using an oil condenser, apply a drop of oil to the condenser's lens. Once the condenser is installed, raise it until the oil makes contact with the bottom of the slide. If using an oil objective lens, apply a drop of oil to the cover slip, then gently raise the stage until the oil makes contact with the lens. Now you can fine-tune the focus. If using a variable aperture lens, adjust the iris to fine-tune the contrast.